Okay, 7.3 part 2, graphing log functions. Let's do a little review for exponential functions. And I believe we did quite a bit of this on a calculator. So I'm going to kind of do this pretty quick. Let's see. Grab a calculator. So this is review from 7.2, 7172 part 2. Okay, graphing exponential function. So I'm going to put in here my y equals 10 to the x. So 10 raised to the x. Graph it. And I'm going to get some good points. So I'm going to go to my table. I'm going to go to my second graph key, get some good points. And let's see, I want whole numbers really. Well, 0, 1 always works good. I have a 110. Now 10 is the limit of my graph. So that's going to be my limit here, 110. And I'm going to use 0, 0, 1, and negative 1, 1/10. And then I've got negative 2, 1/100th, or 0.01. I'm going to graph those points. See, 110. I already know it's a growth model because my base is a bit larger than 1. 110, 0, 1, negative 1, 1/10, and even smaller for negative 2. So my exponential function is going to hug this x-axis and then go up exponentially when I hit positive numbers. So there's my graph of 10 to the x. Now, the y-intercept. My y-intercept, where does it cross my y-axis? That's at the point 0, 1. The asymptote, well, that's where it never hits. It comes close. My function comes close to a line, but never touches or crosses it. Happens to be this line, which is the x-axis, right? And the equation for the x-axis is y equals 0. So the asymptote is y equals 0. Domain, as we learned, again, when we were graphing exponential functions, as I get, as I go to negative infinity for my x values, my function goes to negative infinity. As my x values go to positive infinity on my x-axis. Now remember, this is slightly going up here. So eventually it's going to go to positive infinity for my domain. And again, as we learned, this was always true for exponentials. Always, the domain was negative infinity, positive infinity, always for exponential functions. Okay, the range changed for exponential functions. My smallest y value here. Well, here it tries to get to y equals 0 value, doesn't quite hit it, but it tries to get to that y equals 0, doesn't get it, so we get used to parentheses, and my highest value for my y is my function tries to hit positive infinity. So Let's review for graphing exponential functions. Now, this unit starts by graphing or section graphs logarithmic functions. Now, these two functions here, exponential functions, y equals 10 to the x, and this function, y equals log. Remember, if there's no base there, it's 10, common log. Y equals log base 10 to the x. These are inverse functions. And what do we know about inverse functions? A couple of properties. Well, we know that the x and y switch. The domain and range switch. Okay, so here's my x's for my exponential function becomes my y's. So I have -2. I'm going to make this a little smaller. There we go. So my x's, -2, become my y's. -1, 0, and 1. And my y's become my x's for the inverse. 1 over 100, 1 over 10, 1, and then 10. Also, another property, they reflect about the y equals x line. Yeah, my y equals x line. There's my y equals x line. Okay, so I know that this exponential function is going to reflect or flip about that line. So I'm assuming I'm going to have some kind of shape here. Okay. So let's plot these points and draw our inverse. -2, or actually my x is 1/100th, just barely have here, -2. Let me see if I can, I think I'm going to try using a brighter color. There we go. 1/10, -1. So 1/10, -1, 1, 0, and then 10, 1. So as I look at this is going to get closer because remember we're flipping this. This is going to try to hit this asymptote instead of a y-intercept. We now have an x-intercept, and it goes out to 10, 1. Okay, so let's see. Here's my log function. That's the inverse of this exponential function. So let's review the properties of inverse here. Instead of a y-intercept, I now have an x-intercept. Instead of a horizontal asymptote, I now have a vertical asymptote. My domain, what do you think that's going to happen with the domain and range? I'm just guessing here, but I think they're going to switch. And we know they're going to switch because it's in a property. So let's just go ahead and figure these out and see if they indeed everything matches up. So my x-intercept. Let's see, my x-intercept is when my y value is 0. So it surely does just flip. My vertical asymptote, instead of y equals 0, okay, y equals 0 is my x-axis. This is going to be x equals 0, or my y-axis. Domain. Well, as my x values get smaller, go to negative infinity, my y value, or my y values for the function go to negative infinity. I'm sorry, as my x values get smaller, my y, and actually my x values never get to a negative number. They get to 0. So we can't go any smaller than 0. Never touches that 0. Okay, so see how it gets really close? Remember, when we get to negative numbers, yeah, as that number gets smaller and smaller, it gets really close but never touches 0. Can't go to negative 1. We don't have a negative 1. It's impossible because it would cross that, that y-axis. And then as my x values get larger, my function goes towards infinity. Okay, my range. As my smallest y value that my function goes to is negative infinity. Oops, I was going to put 8. Negative infinity. And infinity is always in parentheses. My highest y value, well, let's see, highest y value. Now, this is angling up a little bit. So it's going to try to get to y infinity. So if we look at these, they indeed switched. The domain and range switched from the exponential function. So since this domain is always negative infinity, positive infinity for the exponential function, this range, negative infinity, positive infinity, is always going to be true for log function because they're inverses. Okay? Well, that's how you graph a log function. Now, just for the heck of it, let's put it in a calculator. We know we can do it on calculators. So let's, just like we can do exponential functions, graph them on calculator, we know we can do the log functions. This is a common log, log base 10, and we do have a log base 10 key on our calculator. Okay, so go to our y equals. This time I'm going to put in log base 10, common log, of x. And then I'm going to graph it. And here's my graph. Well, it doesn't, let me see if I can have this show up better. It doesn't quite look like my function here. See, my function here, it's missing this part of the line. Now remember, as I get closer, I'm at 1/10, maybe right here, and then 100th, a little closer, maybe a millionth, closer to x equals 0. This line is getting so close to that y-axis. The problem is my calculator, although today's technology is much better than it was, doesn't have enough pixels to show the closeness of this function getting the line. So on a quiz or a test, if you just put and do this with your calculator, you're going to have to remember to extend that line because your calculators are not capable of putting that extended line in there for the function. Technically, it's wrong. So keep that in mind when you're doing these problems on a quiz or a test, or even on practice worksheets. Just get in the habit of doing it manually for log functions. Okay. So let's talk about transformations here. Since again, this is the parent function of the, just like this is the parent function. Remember all those parent functions we have, y equals x squared, y equals the absolute value of x. Well, this is a parent function, y equals the log of x. Okay. So let's talk about transformations. Remember, transformations always went off of that equation, y equals a, and whatever symbols, whether it was absolute value bars or even quadratics, remember vertex form, x minus h plus k. Well, again, that's going to apply to log functions. Remember, h tells us left or right, and it's always opposite the sign. So if I have a -2, I'm actually going right to opposite the sign. And the k tells us up or down, and it's the same direction as the sign. So if I have a +5, it's going to go up 5. If I have a -5, down 5. Okay, so let's look at our problem here. I have y equals log of x plus 4. Okay, so here my h is, remember, it's got to have a minus there. So since this is +4, I have a minus minus 4. So my h is opposite the sign. So my h is -4 here. My k, what am I adding outside the mathematical symbols? Well, I'm not adding anything, so it's 0. So my transformation, and there's no a, so my transformations, the only one I have here is opposite the sign. You would think that this would be right 4, but it's actually left 4. That's why we say it's opposite the sign, because it's actually a -4. So left 4. Vertical asymptote. Well, you know what? Let's look at this other problem here. Our vertical asymptote here was x equals 0. Okay. Well, if I go back and look at the parent function here, if I put parentheses here, what am I actually adding or subtracting from x? Well, since there's nothing there, it's a -0. And then my k would be +0 because there isn't one there. So that's how I got my vertical asymptote is x equals 0. It's actually my h. So my asymptote for log functions, just like exponential functions, my vertical asymptote is x equals h. My horizontal asymptotes for the exponential was y equal h. For the log, it's a vertical asymptote, and it's x equal h. Okay. So what's my h again? -4. Well, so I'm going to have a vertical asymptote at x equal -4. Okay, next, my domain. Well, I know the range is easy because remember, the range for all log functions, negative infinity, positive infinity. My domain, well, I'm not really sure. I can't think of it off the top of my head, so I'm going to go ahead and graph this and see what happens with my domain. I'm thinking since I have a vertical asymptote at -4, okay, here's my x equal -4, my vertical asymptote. I know I'm just thinking this off the top of my head. So this is the line x equal -4. I'm just thinking, my parent function started at 1, 0. And if it's -4 here, so I'm shifting to the left 4. 1, 2, 3, 4. I'm thinking, and that's the only shift we have. Same with our point 10, comma 1. So my 10, comma 1 is going to shift 4. 1, 2, 3, 4. It's now at 6, comma 1. I'm just thinking here, thinking out loud, that my new function here is going to go through that -3, 0, and that 6, comma 1 here. Oops, I'm sorry, I didn't have it right. So my 10.1 shifted over 4. 1, 2, 3, 4 now becomes 6, comma 1. My 1, comma 0 became shifted over 4 to the left. 1, 2, 3, 4. -3, comma 0. And it's going to hug that asymptote at x equal -4 vertical line, but never touch it. And here's a sketch of pretty good sketch of of this particular law. It's the parent function shifted 4 units to the left. Okay. Now, my domain makes a lot more sense. Now I can see it. My domain is going to go all the way out here to my vertical asymptote at -4, but it's never going to touch it, so it gets that parenthesis. And then it's going to go out to positive infinity. So here, I can make an assumption here and say that my my domain, I know the range is always going to be negative infinity, positive infinity for this because I said so up here. So this actually becomes my h. See, my h is -4. And now we got to be careful because this a can be a -1 and not just a +1. And this problem is +1. That's why we don't see anything here. If it's -1, this could be negative infinity. So it's either going to be positive infinity or negative infinity for my domain for all log functions. So there's a lot going on with log functions, as there were with exponential functions. Okay, page 2. A couple more examples. Natural log. Tell you what, let's do the bottom one first because that's common log, and then we'll go back and do the natural log. So here, again, got to watch formula here. Y equals A log, oops, I forgot my log, log of x minus h plus k. So let's see, my h for this problem, what's being added to x inside? Well, my h is 0. Nothing's being added. Okay. My k, now this has to be a plus sign, and it's a minus sign. So my k has to be opposite this sign. If this was a plus sign, it would be positive 5. But because this is a minus sign, my k has to be negative 5. Because then I would have a minus negative 5, which would give me my plus sign. So this is technically a negative 5. Okay, what else do I need? That's it. Okay, my couple of things we learned here. Vertical asymptote is x equals h. So my vertical asymptote here is going to be x equal 0. My domain, let's see, we figured out what domain was, right? I should have separated this a little more. Okay, my domain we figured out was from the previous problem. The domain was our h plus or minus infinity, depending on what our a was. Okay, so my domain here is h, which is 0, and our a here for this problem, well, there's no negative sign in there, so it's going to be positive infinity. In fact, we know for sure that that's what my domain is, so I'm going to put it in. My range, remember, range is always for log functions is negative infinity, positive infinity. So I already have half of this filled out. Vertical asymptote, whoa, look at that. I got x equals 0, so I got that filled out. Transformations. So I'm looking at my h, k, and a. We haven't talked about a, so I'm looking at h and k. Well, my k is going to go down 5, down 5. Now I could do this without the calculator. Okay. Let's see. Vertical asymptote. X equals 0. X equals 0 is our y-axis. This is x equals 0. It's going to go down negative 5. Now, if you can remember that our parent function x-intercept is 1, 0, we know that this is going to go down 5. 1, 2, 3, 4, 5. So I got my vertical asymptote and then my point 10, 1. Remember, these are my key points for the parent function. My x-intercept was 0, 1, 0. Okay, that was the x-intercept. 1, 0, 1, 0. Then I'm going to go down 5. 1, 2, 3, 4, 5, because that's what K was. And then my other key point was 10, 1. There's my 10, 1. I'm going to go down 5. 1, 2, 3, 4, 5. And it should be negative 4. So it's going to hug my y-axis, turn at the x-intercept, what was the x-intercept, and go out to that point there. So I could do this without a calculator. If you want, you can do that calculator thing, but remember, you're going to have to extend the line. So let's look at our y equals button. I've got log x, close off the parenthesis, minus 5, and graph it. And I noticed right off the bat here, I do not have that extended line, but that's okay. Let's see, let me get some key points here. Go to second graph. And here's a good one, 1, negative 5. Now this is from the calculator. So from calculator. This is from the parent function. This is from calculator. I got a good point of 1, negative 5. And let's see if I can get another good point here. Oh, 10, negative 4 is a good one. Okay, so 1, negative 5. Well, there it is. And 10, negative 4. I get the same points whether I use the calculator or whether I use the parent function and just count the shifts up or down and left or right. Either way, just if you use a calculator, remember to continue this down, this function down. Okay. And that's exactly what I did without technology. So I did both of them for you. I did it by hand first without a calculator, then I did it with a calculator. Okay, real quick. We have what's called the natural log. Natural log just replaces the common log base 10. Well, it doesn't replace, but it's same. All the transformations, everything in mathematics manipulation is done the same way. Instead of log base 10, we have the natural log. Okay? Everything else works the same. So my h, and I'm using this down here, my h is, it's a positive 2 because I don't have to change the sign. I already have a minus sign there. H is positive 2, which means it's going to go opposite sign, right 2. My k, what am I adding to the outside of the mathematical symbols, in this case parentheses? 0. So my vertical asymptote is going to be x equal h. And my h is 2, so I have x equal 2. My domain is going to be my h plus or minus infinity, well, my h is 2, and my infinity, the sign in front of the infinity is going to be positive because my a is positive, and my range, always negative infinity, positive infinity for log functions, even natural log. Let's graph this. Vertical asymptote 2, x equal 2. If I do it without a calculator, my shift is right 2. So I'm going to do my 1 comma 0. So go right 2, 1, 2. And my 10.1 is going to go right 2, 1, 2. And here is the graph of ln of x minus 2. Now, I'm going to check myself because, I do have memory problems. Okay, so instead of log button, we're going to hit the ln button, which is right underneath it. X minus 2, graph it, find some good points. Second graph. So from technology, from calculator, I get a good point of 3, 0, and I'm going to get another whole point, a whole number here. Should be 12, 1. It's not showing me. ln of 10, 2.3. Weird. 0, and then 10, 2.3, 12. Let's do ln of 12, see what happens. 2.5. Should move up or down. Well, we could. I'm just going to say it should be 12.1. Something's going on with my calculator. I'll have to look into it. All right, that's it for this section. We're going to do a lot more with ln and see what happened here in this discrepancy. I'm not sure what's going on here. All right, that's it. So you're good to go for the homework.